Hey everybody, I'm your host, John Myers, live from Stillwater, Oklahoma. We have got a great show tonight. It's John Myers. Hey everybody. Gotta have my notes. It's John Myers from the Kicker UnMasked studios. Gotta have my notes. Alternator. Hey everybody. We have fun. Hey everybody. Hit like and subscribe. Right here, right now. It's John Myers. We like to give stuff away. Alternator. Post some more pictures. We got to thank Steve and Becky live from Stillwater, Oklahoma. Don't forget Texas Roadhouse right here, right now. Hey everybody. Don't forget right here, right now. We have got a great show tonight. Hey everybody. Had a great dinner tonight. It's John Myers. Right here, right now. Had a great dinner tonight. So, hey everybody. So, housekeeping. Had a great dinner tonight. So, alternator. Housekeeping. Housekeeping. So, Tuesday night. Housekeeping. From the Kicker UnMasked studios. Housekeeping. Right here, right now. Hey everybody. So, it's John Myers. Hey everybody. It's John Myers from the Kicker UnMasked studios. Hey everybody. From the Kicker UnMasked studios. It's John Myers. Right here, right now. We have got a great show tonight. Hey everybody. We have got a great show tonight. It's John Myers. Hey everybody. Right here. Hey everybody, it is Tuesday night, Unmasked. Thanks for showing up. I think you just saw a little brief picture of what we're going to talk about tonight. Hey, if you guys didn't see last week's show, you need to go back and watch it. It was a really good show, and I missed it too, but I was having more fun. I was somewhere off the continent, with volcanoes and stuff, but we won't go there because I already did. Anyway, it was a great show. This week we got the usual array of suspects. We got Steven behind the camera. We've got Ernie and JW back behind the computers. And of course, none other than Bill Frog answering all your questions. Want to thank all you guys for tuning in tonight. Thank you guys for your support. If you're new to the show, make sure you like and subscribe. Tell your friends, tell your neighbors, wake the kids, and shave the squirrels because we're going to have some fun tonight. Just remember, if you guys have questions, support@kicker.com. And as always, we'll talk about what we're going to give away right after the break. So when we come back from the break, I'm going to have my co-host Jacob join me up here because he's going to keep me in line because we have a ton of stuff to cover and I'm bound to forget a bunch of it and he's going to have to keep me on track. So we're going to be talking about test equipment, how to use it, why to use it, and what to use it for. So tune in right after the break. We'll have Jacob up here and we're going to dig right in and have some fun.
It's been a long road since the original Kicker christened that first pickup truck. It kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machines became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is Kicker.
And we're back. Welcome, Jacob.
Hey, what's going on?
Ready to have a fun show tonight?
Oh yeah, we've always got some good stuff planned for you guys, but I think tonight's going to be especially fun.
Yeah, this is going to be crazy. I mean, we got so much to talk about, but I guess the first thing we need to talk about is free stuff.
Free stuff? You mean
People
like giveaways?
always like free stuff, so if you guys are new to the show, you probably heard, and if you haven't, you're going to hear it right now. We give away stuff on every show. We generally have three groups of winners, or three winners in different categories. So the third place winner, which is the runner-up to the runner-up, they're going to get the, still got the tumbler over there? Nope, it got off screen. So we got the Kicker tumbler. You're going to get the Kicker UnMasked t-shirt that's behind me and a Kicker koozie. The second place winner is going to get the EB400 Bluetooth earbuds, the koozie, and the t-shirt. And the grand prize winner is going to get the Bullfrog 100.
Bullfrog 100.
Waterproof Bluetooth speaker, the koozie, and the t-shirt. So that will be exciting. So guys, make sure you register at kicker.com/umweekly. We will end that in about 26 minutes at 8 o'clock Central Time. So if you guys are not tuning in live, make sure you tune in to the next show when we are live so you can register to win as well, because unfortunately, it only works if you're live.
Yeah.
So when we get close to the end of the show, which I hope will be before midnight.
Oh, it'll be before 10 o'clock at least.
God, I hope so. But man, we got so much to cover. But we are going to talk about test equipment today. And I got to make one statement up front. We're not going to show you all the options. Obviously, that's just not physically possible. So if there's other things you guys are using, and you want to let us know what you use. If you're using something like this and why you use that. We're going to show you just a couple options up here. There are many more options. I mean, there's more expensive options. There's cheaper options. I tend to shoot kind of we're in the middle, stuff that does a really adequate job but doesn't break the budget. Because the whole point is we're using the tools for better audio, and if you're doing this professionally, you're using it to make money.
Yep.
I always thought that was bizarre going in some of these install bays. The guy has a $25,000 toolbox from.
Yeah. And
it's status, right?
Right, it's status, and a lot of it depends on what you're actually doing. So, like, you're going to want to go after the more expensive tools, like the really, really expensive oscilloscopes if you're doing engineering, designing things where that sort of accuracy is really important. But most of what we're doing as installers, it doesn't need to have lab-grade accuracy. So we can use stuff like this EPOOC oscilloscope and handheld multimeters and things like that. Unless you are looking for lab accuracy, then of course you can always buy the more expensive tools.
Yep, there's always something more expensive around the corner. So why do we use these tools, Jacob? Why are these important? Why don't we just do everything by ear?
Well, for us, our ears don't exactly tell us all the information that we need to know. So
well, basically, our ears suck.
Yeah, essentially. But
you think your ears are good, but they really suck.
But your ears also can't measure voltage, and they also can't tell when a sine wave is clipping, and all sorts of other things like that. So that's why we use these tools to help us know what we can't hear.
And how many times have people burned up speakers from distortion that it wasn't distorted? What do you mean it wasn't distorted? Your speaker's smoldering.
Go ask our warranty department.
Yeah, exactly. So we've got several test tools up here, and the SMD meters, I mean, those are some great meters. Well, we may do a show on those a little bit later. It's too much for you guys to take in. If you guys are watching this, hopefully you can see the screens. I mean, I'm looking at this little oscilloscope in front of me, and yes, this is an oscilloscope. They show waveforms. So what you're seeing up there right now, if you look at the radio to the left, it says 60S, which means 60 seconds. That's a sine wave at 1,000 hertz, or 1 kilohertz. I get to hear people that are like 1,000 kilohertz. Well, that's way out of the audible range. So it's just 1,000 hertz or 1 kilohertz. So if you look at the waveform, I mean, that's what we call a sine wave, and that's basically, a file that I've put on the jump drive that you see on the head unit, and you see it just started over again. So that was the track repeating itself every 60 seconds. So what I'm going to do is going to basically mention that the sine wave is what we're going to use to detect clipping. Now, when you start talking about, the sine wave, you've got a positive side, negative side, and you can actually measure the voltage. You've got something on an oscilloscope called volts per division. So if you can see the screen close enough, and I don't think you can looking at our TV over here, there's actually little dotted lines that go horizontal. And that's voltage per division. So we have it set, in fact, I'm going to guess right now, probably wrong, so I'm going to read it. It's set at 5 volts per division. So between those lines, every line is going to be 5 volts. So if you had 4 groups of lines you're crossing, that's a 20 volt signal. Obviously, we start talking about peak versus RMS. We don't want to get too deep into that.
Yeah, I was going to interject and say that there is a difference between peak-to-peak voltage and RMS voltage. And RMS voltage is what your multimeter is going to tell you. And then peak-to-peak is going to be a more accurate rating of your voltage, and that's generally what like an oscilloscope will tell you. But thankfully, this one has a capability to show you both. So if you want to see your RMS voltage, that's generally what we deal with in car audio.
Yep, and if you want to know how to convert it from RMS to peak, you take the peak value and you multiply it by 0.707.
Yep.
So that's how you actually figure, you know, the RMS voltage from peak to peak. So looking at this sine wave, as I turn this radio down, if you zoom back in on the oscilloscope there, Mr. Ernie, or Jeremy, I forget which one of you guys was running the cameras back there. So if you notice, as I turn the volume down, we see that sine wave starting to flatten out. And what's really cool about the oscilloscopes is you can change, this one's really cool because you can actually change it just by touching it. So it is touch sensitive. That is not an expensive piece of equipment, guys. That's $149, I think I looked it up last week on Amazon. So, and it's a dual trace. Now, dual trace means it'll actually measure 2 signals and show it on the display at one time. We're not going to do that with this one. It does have the capability, but I've got another laptop over here. We're going to show you pretty much the same thing. You'll probably be able to see it much better. The other thing you can do is you've got the voltage per division. You can actually change that. So as I touch this plus over here, you see that jumped up quite a bit. Now it's down to 2.5 volts per division. So the waveform got bigger because we've got less voltage between the steps. So let's go back to, now it's completely off the screen, so you can't even read it. So we'll keep touching that and drop it down. And you can really get crazy with, you know, stretching that sine wave out. And the reason you want to do that is you want to get the most visible waveform. And it's all in the setup, and don't be afraid to experiment with it. It's really handy to have. So oscilloscope without like an SMD1, you know, the distortion detecting meter, which clipping detecting meter, you know, you really can't see clipping unless you have an oscilloscope, and you can't hear it. You know, it's funny if you guys try to test yourself, you know, try to, you know, turn it up till you think you hear distortion, then look at the oscilloscope and see how far off you really are. But this is actually a clean signal. So I've got this radio, if we look at the side, that's at 25 right now. So as I turn it down, of course, you're going to see that completely disappear. And we can really turn that scale and that waveform down, but it pretty much looks like a flat line. It's dead. It's flatlined. It's dead.
Yeah, hopefully not.
Nope, this isn't a doctor show, but let's go ahead and keep turning this back up. And hey, if you notice, it is not actually responding anymore, which is very interesting.
You probably bumped something.
Well, we got so much test equipment up here. There's so much static and, you know, things going on. And don't be afraid if you don't like the reading you're getting to reset it.
Yep. In the meantime, while John is working on getting that to go, I noticed somebody in the chat had a question. So why are the cheap oscopes so bad or worse than the more expensive ones? So I actually took and compared this oscope to the ones that we use in R&D to work on our amplifiers. Just kind of a rough, you know, comparison. But one thing I noticed right off the bat is that the voltage that this displays is a little bit inaccurate compared to the ones in R&D. And so if you're measuring like a 10 volt signal, the one in R&D would say 10 volts exactly, and this one might say 9.72 volts. It's not a huge difference, but it is enough to make a difference if you're working on something that requires that kind of accuracy.
Well, and the other point is, you know, we're looking more at the waveform than the actual voltage.
Exactly.
We don't care so much, you know, what the actual voltage reads. We're more interested in seeing the waveform, and that it doesn't lie.
Yeah, exactly.
And the other big difference in price is you know, size of display.
Yep.
I mean, some of the oscilloscopes, I got a display this big, and it's really hard to read the waveform. And, you know, depending on the quality of the screen, you know, pixels per square inch, I mean, that makes a big difference as well.
Some of those ones use like the old style, like alarm clock screens where the pixels are huge and you wouldn't really be able to see when it starts to clip as you would with one that has a much higher resolution. So just a couple reasons there.
Cool.
But anyway.
All right, so where were we? I think we're at 25 or so on this. I can't remember. Let's go down. We're actually at 28. So we're going to figure out where this clips. And what I'm measuring right now on this oscilloscope, I'm actually measuring the speaker output of the head unit. So this is going to tell me when the speaker output clips. So as I turn this up, go to one more. If I go to, what happened, Jacob?
Looks like that waveform started to clip. You guys notice how it got flat lines on the top and bottom of each one of those swings of the sine wave?
Back one click. That is 27 on the scope. Go up again, there's 28 and 29. So this head unit, the speaker output, is going to clip playing from the flash drive at 29. And that's something else we're going to show you. It depends on the signal and the source. It's very important that you set your systems up for the signal and the source and the type of music you're going to be listening to, because different types of music is recorded differently. So as we keep turning this up, what if we go beyond? So we're just at the clipping point right now. What if we go even farther? You really see this starting to flatten out. Hopefully Ernie can switch back over to the screen there. There you see it. So
if you guys notice, it's not getting any taller or further going down to the bottom either. It's just getting flatter and flatter the more you turn it up.
And that's at 35 on the output of the head unit. So that's all the way up. And if we start backing this down to 28, there we are. So we know the speaker output when playing from a flash drive with a 0 dB signal, and this is recorded at 0 dB, you've got -5, -10, and you know what we're talking about there is how loud the information is recorded on that flash drive. So 0 dB is considered the most accurate, but if you want a little bit more output, you're going to have a little bit more distortion. You can use the -5, say, for just a little bit, less clean signal, but a little bit louder, and then of course the -10 for setting up a subwoofer, because you probably can't hear the distortion anyway. But for the most part, we're just going to talk about 0 dB signals. We might show you that on one of the other episodes when we start talking about some of the other meters. So what's really interesting, there's another program that I'm going to be using probably several times tonight, and it's on a laptop. And this program is called True RTA, and I'm going to open up my laptop here, and then I'm going to have Ernie turn it on. It's going to do that facial recognition thing. Technology is so crazy that it actually knows you by looking at you. So what I'm going to do now is I'm going to open this program, and it's called True RTA. I'm going to go ahead and turn this all the way down. And sometimes with everything going on here, this program does get a little bit squirrely, and it may lock up from time to time. But if Ernie, you can pull up the laptop now. So what you're seeing the blue signal, which is going to be the RCA output. So we're measuring both at the same time. We can do that with what we call a dual trace scope. The other thing the dual trace will do, it'll measure the left and right channels at the same time. What we're doing right here, everything should be matched. The bottom is going to be measuring the speaker output. And as I start to turn this up, you can't see it now, but I'm on 25 on the output of the head unit. You see both of those are a pretty clean signal. Let's go ahead and go up to where we said 28. Now, both of those are nice, clean waveforms. Neither one of those is clipped. But what happens if I go a little bit louder? What happened to that signal on the bottom there, Jacob?
It's starting to clip.
And that's the speaker output.
It's more of a soft clip at that point.
Yep, so let's go up another click. Obviously, you're seeing the top waveform, which is the RCA, is still clean. That's at, I think, 30. How far can we go with this?
I'm going to take a guess and say we can just about get up to max volume with that.
So there's 34 out of 35, and we can change the range on this so we can see that a little bit better. If we drop that down, now you're seeing a big difference in those waveforms. So if you use the speaker output to set your gains and then switch back to the RCA, you're going to have some problems with distortion. In fact, let's go all the way up on this head unit. I just wicked it clear to the top. And if you notice, the top and bottoms of that blue waveform show just a little bit of clipping at full volume. And I can actually go through and I can, with the scale over here, you can see we can space that out a little bit farther. So if I go back one click on the head unit to 34, we're back to a clean signal. That's what I wanted to show you guys, is that it makes a big difference what signal you're feeding into the amplifier. And you need to check the signal, the clipping on, both, or figure out which one's the cleanest and which one you're going to use for the setup.
Yep. Sometimes you can go online and maybe you'll find something in a forum that says so-and-so radio clips at 28 on the volume, but a lot of times they don't specify if it's the speaker output or the RCA.
Yeah, they almost never do.
And you can see that there was quite a bit of a difference in the volume output there, comparing RCA to speaker level. So it's very important to test it yourself if you have the means and the capability.
Absolutely. Now, something else, the odd thing about the waveform on the laptop is I'm actually going through an interface, a little mixer, and we're going to show you that in just a minute because it's going to be very crucial in something else. But it has its own input sensitivity. So I can adjust those waveforms independently. So you can't really use the voltage per division scale, because I've got another control in the middle of that that's changing it all again. In fact, Ernie, go ahead and go back to the laptop view again. Got a nice glare on that, sorry. So if I adjust the signal on the left or the right, and as I mentioned before, with everything going on here, sometimes this will lock up, but it'll just take me a second to fire it back up again. Nice. I love how quick that is.
Nice wallpaper.
Isn't that? All right, so as you can see by that top, now they're both clipping, and as I turn it down, so I can change the sensitivity on both of these. So that's why it's important to know what you're using for a source. So for the oscilloscope, we're not using it to measure voltage as much as we are using it to look at waveforms. All right, so let's talk about one of the most important tools in car audio.
DMM, right?
Yeah, how about your phone?
Oh.
I mean, probably not the most important, but maybe the most common. So this is going to be a tool that you can use if you use it correctly. So obviously, cell phones, there's a couple different ways you can get signal out of them. You can Bluetooth, you can run it out, the audio output of the phone, the headphone jack, but this is I think it's a
You don't know what
Galaxy
phone you have.
21. Yeah, it's a phone.
I'm teasing. They've got so many Galaxies. I don't know which one I have.
So this uses a USB-C, but there is no headphone jack on that.
Right.
So you might be thinking, hey, I can only use this for Bluetooth to send signal. Well, not necessarily, because there's this cool little adapter, and I know I had one. There it is. Like I said, I've got a bunch of test equipment back here. So this is a USB-C to 3.5. So I can plug this into the headphone, and if you don't have a USB-C, if you have a 3.5 millimeter jack, you can do it that way as well. So what I'm going to do next is I'm going to grab just a 3.5 to 3.5 cable. Nothing fancy, just a little headphone cable. I'm going to plug it into my phone. Now, I'm going to go to an app that I have on my phone, and if you guys go to the Kicker U app, if you go to the App Store and type in Kicker U and you buy this app, it does a lot of things. I mean, you manage the drivers, you can put your own speaker drivers in there. You've got a box builder, you've got saved enclosures, port converters, tuning frequency calculator, airspace calculator, power wire calculator, wiring wizard, which will tell you how to wire multiple speakers of different impedances and numbers of voice coils, tone generator, that's the one we're looking for. You have enclosures 101, which is information on building enclosures, and a whole bunch of other really interesting things. But what I want to do is I want to go to the tone generator, and I'm going to have this set on 100 hertz, and I'm going to hit start on my phone, and I'm going to turn the volume of my phone all the way up. And I want to know how much output does this phone have. We always talk about, output voltage is very important. The higher the output voltage, the better, because the less your amplifier has to amplify the signal, the better off you're going to be. So we're going to go ahead and leave this at full volume. I'm going to set it down, and I'm going to pick up this little tool right here. This is not an expensive multimeter. Does that say Radio Shack? It does. Does Radio Shack still exist? But this is just a common, $15, $20, $30 voltmeter. So don't tell me you guys can't afford to get a voltmeter. You don't have to have a $300 or $400 fluke. I mean, if you have one, they're great. They're, obviously quite a bit more accurate, but these really do a decent job. Now, the big key is you want to have at least one place behind the decimal when you get a voltage. 2 would be even better, and of course 3 is even more accurate when you get in the more expensive oscilloscopes. But all I'm using this for is to measure the maximum output voltage of the phone. Why would we want to do that?
So that, we know what input level to set our amplifiers. We don't want to have it set to high level if it makes a low level signal.
So if for some weird chance that phone has a 21 volt output, and I've got an amplifier that only has a 4-volt maximum input signal, we know we can't run that phone at full output. You're going to clip the input to the amplifier, and once again, if you clip the input, you're guaranteed you're going to clip the output. It can't fix that signal. So that's the reason why we want to know what the voltage is coming out of whatever device it is. And we're going to show you with the phone just to make it a little more interesting. So I've got the voltmeter set for voltage, DC voltage, I believe, which is wrong because we want to measure AC voltage.
Right.
We're not measuring battery voltage, the straight constant voltage. We want to measure that waveform between the two peaks, how much voltage is there. So I'm going to try to do this with one hand, and I'm going to try to hold these test leads across this, which, like I say, it all gets kind of challenging and interesting. All right, so I got this thing cranked up pretty much all the way. And with that 100 hertz tone, I don't know if you guys can see the voltmeter or not.
Looks like about half a volt.
Yeah, it's not a lot of output, half a volt. So that's interesting. I only have half a volt of output, but is that clipped? Playing that 100 hertz sine wave. How do I figure out if it's a clipped signal?
Use the oscilloscope.
Probably use the oscilloscope. And then we're going to show you, we're going to come back to this meter because we're going to show you how you can actually set gains with the meter. Hopefully we'll get time to do that later in the show. So we're not done with that little guy yet. So we're going to go back to...
Which one are your leads here?
Yeah, I know. I'm trying to figure out which one's going to be easiest to do this with the phone.
I don't know where it's going. It looks like it's channel 2 on the E3.
Yeah.
So
we're actually going to go to channel 1. We're going to use this one. And that's something else that's kind of interesting with the oscilloscope meters, or the leads, they're a little bit different. The voltmeter leads have probes or alligator clips. This has got a probe that you see here in my hand that's got this little hook that you pull the little sleeve down, it'll hook onto things, and that's generally the positive connection. And the little alligator clip is the negative connection. That's one type of test lead. And then you also have them where you can have alligator leads or you can have the little hooks on both of them. So it really doesn't matter as long as you have a good set of leads, but something that's really important about this style, the wand style of lead, it's got a little switch on it. This little switch is important because this is a ×10 switch. So whatever this reads on the scope, you have to multiply that reading by the factor of 10. So if it reads 2 volts peak to peak and it's in the ×10 setting, that's 200 volts peak to peak. So that's why this one's kind of handy. But obviously with the phone, we're not worried about 200 volts. So we want to make sure we have it set in the ×1. And then I'm going to go back to my output on my phone here. We'll see if I can do this with this one again.
it might be easier with the hooks.
Yeah, it might be. So that's what I'm trying to do. And these little hooks don't have a really big radius to them, so that can be a bit of a challenge. In fact, we might get to a point where I may make you hold it here, because it's not wanting to stay on here. Look at that.
Let me try.
All right, so I'm going to have you hold to the... You're going to actually use the tip, which is the very end of the 3.5, and one of the sleeves. And we'll go ahead and crank this up, and I've got to set my voltage range. We're at 5 volts per division. We want to drop this down. We're going to start down to 100 millivolts per division. Yeah, you're just going to probably have to hold them on there.
Doing my best. See if that works. Are you getting a signal?
I'm not getting a signal. So I'm gonna... And that doesn't mean my phone's not playing a signal either. So this is actually a really cool little scope.
Oh, yeah. There you go.
All right, so you can see the waveform, and we need to adjust this waveform, and we need to adjust the voltage because we actually have more voltage than I thought we did coming out of it. So you see it's got a little bit of static through that waveform. It's not perfectly clean, but here again, it's such a low voltage, it's picking up static in the ear too, which you won't have in an audio system because that signal's going to be grounded. You're just using half of it. So, but even with this phone all the way up, you notice it is not clipping. So let's go ahead and drop the signal down. You can see how the signal moves, and it looks like a pretty big jump with every click of the volume control. It's not a real smooth graduation. So we know that using a sine wave output on that phone is a clean signal at full output. Now, it may not be that way with music, but at least we know with a sine wave, and it's almost impossible to see clipping with music. That's why you use a sine wave anytime you're testing for music. But that's not the only thing we need to test for. So we know that that's got a good, clean output with the sine wave at maximum volume. What about frequency response? What would we use to test frequency response on the phone? What type of signal do you think there, Jacob?
Low level and using an RTA.
An RTA, exactly right. So there are really expensive RTAs. You guys remember the old audio control 3054s, about $2,000? Great RTAs. I mean, they really were. They did a lot of cool things. But for those of you that don't know, RTA stands for real-time analyzer. Hope you guys just didn't read my security code for all my high-class information that's on my iPad.
Yeah, like Netflix.
Exactly. I don't think I have Netflix on here. I don't even. No, but I have the RTA app. So the iPad has got a good screen. I mean, there are some smaller RTAs out there. I mean, you can use the laptop, which I've got an RTA function on the laptop. We'll show you that here in just a little bit too. Just another, possibility of an RTA. You can use your phone, but it's got a much smaller screen. I mean, I would rather have as big a screen as possible. So what we're going to do is we've got an RTA app. Now, if I want to know what signal is going to a speaker, an RTA is great when using a microphone for tuning a system for sound quality. So what you would do is you put the microphone in the listening position of the vehicle, you would play paint noise, which is supposed to be equal amounts of all frequencies, and you would watch this display in the RTA, you see it's moving as I talk, and you would be able to compensate for any peaks or any valleys. So that's how you use the microphone and an RTA to set frequency response when you're listening to it. But for evaluating the system, you cannot use the microphone because it's going to pick up all the outdoor noise that we have. Plus, speakers don't have a full range output. I mean, speakers have bandwidth. They also have, their characteristic EQ curves, so they're not going to be a flat response either. So even if I were to play the paint noise through that speaker and use the microphone, you would see that it's not a very flat signal whatsoever. The next thing we need to do is we need to figure out how to get speaker level signal into this. If we're not going to use the microphone, how are we going to get the signal from speaker leads, which can either be an RCA output or an amplifier output. And we've got a little device here that we made, which is actually pretty simple and pretty cool. I've got a couple different versions of it. Where's the...
You're looking for this probably.
I was actually looking for this one down here. The one that fell off the table.
Oh. Yeah, that'd be why I didn't see it.
So this is an interesting little tool. And if you guys want to know how to make one of these, I'm going to tell you, but you can also look it up if you go to the tech papers on our website, on the support tab. There's a tech paper, there's building a simple RTA and testing output. So this is a very simple version. This is the first rendition that we built, which basically just uses a set of meter test leads. So these are a set of meter test leads you can buy pretty much anywhere, Amazon, most electronic stores. And we're going to cut the ends off that plug into the meter because we're not going to use those. Now, you cut the ends off the meter, don't throw those away because you can make another very useful test piece of equipment with the ends. And this is where I've taken the ends that would normally plug into the multimeter and I've attached them to an RCA cable. Now I can plug these into the multimeter. I can plug this into the output of the radio or the RCA output of an amplifier, and I can measure the voltage just by plugging it in with an RCA. Now, if you want to measure the signal coming into an amplifier, that's got a male end. You can use a barrel connector, so you can actually plug a male RCA into that. So that's a great use for that set of leads that you cut off, or the terminals that you cut off those leads. So this piece is really cool, as I mentioned, and it just uses a very simple line output converter. I always talk about how line output converters are bad. There are a lot of them that really aren't great. And not that I'm bragging about our line output converter. I mean, I am, but this is not, we didn't intend to make a product to sell it for a lot of money and make a lot of money off. This is basically an installation tool. So I think they retail for like $25 is all.
Something like that, yeah. For the quality you get out of it, it's really a good price.
So with most line output converters that use resistors, that use like transformers, they will saturate. So as you get higher in output voltage, the low and the high frequencies actually start to roll off So at full power, you no longer have a flat frequency response. A lot of them only handle 10 to 15 watts of power. This is rated at 55 watts of power. It does have its separate left and right gain adjustments. So if you're really setting up a system for sound quality, you're closer to the left speaker than you are the right speaker. So you might want to drop the volume down. If you don't have a DSP, this is a great way to do that. So you can drop set the gains appropriately on left and right speakers by using an RTA with an SPL mic, measuring dB output. So we're going to go from our test leads to the speaker inputs. We go from speaker level to line level. It's called a line level adapter. And then you have a very simple 3.5 to RCA. Now that's great. So we have line level here, but phones don't accept line level, do they? They have to have something called mic level, microphone level, which is another notch below line level. So you need something to take this down to microphone level, and you don't have, there's another sleeve on here, which is the microphone input pin. So if you guys have a set of earbuds or headphones that have the two-way talking capability, you're going to see another little sleeve here, another ring, and there you can see it. I'm not sure if Ernie can zoom on that. There we are. Right there, okay. So you can see the gray cable is just the RCA output, which is stereo. The black cable has that extra sleeve, and that's the microphone input. If you guys can't see that, just take my word for it. I know, especially if you're watching the phone, that's been kind of hard to see. But this is pretty much the magic cable. This is a line to mic adapter, and it gives you that RCA, or that microphone input sleeve. So now I go from speaker level to line level, and then line level to mic level. This is available on Amazon for $23. That's probably the second most expensive part of this whole kit. It's called the Headset Buddy, which is the company name, line to mic adapter. So Headset Buddy, line to mic adapter, and specifically designed so you record music on your tablet from a mixer board. It was designed for musicians. What we're going to use it for is we're going to take this signal right here. I'm going to give that to you, Jacob. And I'm going to plug this into the microphone input to the iPad. Now when I do that, figure out where my microphone input is, you're going to see something happen, because if we look at the top here, it says iPad microphone on the top. And this app is called Octave RTA. I think it's about a $4 app. I mean, there's a bunch of free apps out there too, but this is the one that I seem to like. It's just personal choice. But when I plug this cable into this iPad, you see it kind of reset itself. Everything dropped down, and it says headset microphone. So now it's actually using the input from the microphone. And you see a little bit of reading down at the bottom. That is system noise. So system noise is just background noise. As long as my signal is above that system noise level, it's not going to be an issue. So he's over there probing things, and you're seeing the RTA move. You're trying to freak me out there, Jacob. Good job, you did it. So try to turn this so you don't have any glare. So this is going to be used for measuring the speaker or RCA output level of any deck, any head unit, any amplifier. So I think my phone's still playing. Why don't you go ahead and just probe the tip in one of the sleeves.
This is going to be 100 hertz.
Yep, and that's just a sine wave. So if you notice right here, if I touch this, 100 hertz, it's telling you that that's 100 hertz, and you see the extra information on each side. 100 hertz has got a fairly wide bandwidth. It's not just 100 hertz. There's actually a lot of information. But we're not using the RTA specifically for individual frequencies. What we want to do is we want to switch this app over to something called pink noise. Pink noise should be equal amounts of all frequencies. So go ahead and probe that there, Jacob.
Hit start for us there. And
that might help.
if I can get it there.
All right, so if we can zoom back in on the iPad, on one of the cameras, hopefully the one Steve's messing with right now. So there we are. So I'm going to pull this little cursor away. So you notice we got a pretty flat response here. So we're sending a perfectly flat signal into the iPad, and we're measuring it coming out of the headphone jack. I'd say that's a pretty usable signal, wouldn't you?
Oh, yeah.
That's not bad at all.
That looks almost perfect.
So you see that little bit of a drop at 20K? that's because of the filters that are in the iPad. So that's great. In fact, I can't hear 20K, and it's not that big a difference. So don't worry about that little bit of drop at 20K. Every iPad's going to have this issue. So as I turn the volume up and down on the phone, yep, I think we got enough cord to do this. All right, I think you lost signal there. Nope, actually what happened is I touched the phone and...
Stopped the ping noise?
Yes, I did. There we go. So as you turn the volume down on the phone...
You should see the level drop also on the RTA.
Yep. So you see that level drop, and it drops very uniformly. As I turn it back up, it goes up fairly uniformly. Why is that important? Why would we want to know that? Well, there's a lot of vehicles out there, Fords especially, and they're not the only ones, just the one I can think of off the top of my head, that they have what they call basically a dynamic EQ. As you start turning up the volume to protect those factory speakers, they basically hold the bass response where it is. So the high frequencies will continue to rise, but the low frequencies will pretty much stop at one point. And they're doing that to protect the stock speakers from blowing so they don't have to have warranty recalls.
I think some bikes, like some Harleys, also have a dynamic EQ so that, once you get driving fast enough, it tries to play so that you can hear it more clearly over wind noise and things like that. So there's quite a few situations where the EQ might change with the volume. Yeah,
and it takes a lot more power to play low frequencies loud than it does high frequencies. So if you can not make those speakers play that, it's going to sound louder because you're increasing the volume of the mid and treble. So that's why it's important to use the iPad and adjust the volume. Now, what this is really used for, if you're not replacing the factory radio, no one has got a piece of equipment out there that will take the speaker level or signal level coming out of a factory radio and fix that auto roll-off. There are some companies that make interfaces, which are great because they go between the head unit, the display piece, and the amplifier, and they pull out a completely flat, fixed signal, which is great. So interfaces are going to be a little different, but when you're just taking like a 4-channel factory radio, a bass radio only that has bass roll-off, if you want to make sure your system has the maximum bass at the maximum output possible, so as you turn it up, the signal's flat, what you would do is you would turn that signal up till you see the bass stop, and then you would not turn the volume up any higher, and you would use that point to set your gain on your amplifier. So that way, when your amplifier has maximum output, it has full frequency response. So that's another area where this RTA is really, really nice to have. So that works really simple and really easy. What do we have, $80 worth of parts here? And a simple app?
Yeah, maybe not even $80.
Versus a $2,000 3054?
Yeah.
Those 3054s are pretty cool. They got a printer connection to them. But that's why the iPad is really important, especially if you're going to hook up a subwoofer in your vehicle and you've got 10 speakers in the car. You need to know where you can get the subwoofer signal, because not all the speakers have a subwoofer output. Now, I forgot which car it was. There's a Lexus out. It was a 2019 model, and I cannot remember what model it was. It's got 17 speakers in the car. The only full-range speakers are the door speakers. Everything else is crossed over in some way. So on that particular vehicle, you would figure out by using the RTA, I've got to grab the signal from the door speakers to get the low frequencies. Now, they have their own natural roll-off, and like I say, no speaker has a full 20 to 20 flat response. So that's why you have to measure the signal going into the speaker or coming out of the amplifier or the radio for the signal. Now, we had a little problem this year, didn't we, Jacob? With the iPads?
Oh, yeah. So
this is my own iPad, by the way.
Yeah, so we had a whole thing. So first off, I want to show you guys this piece. This is the...
See, I almost forgot that. Good thing Jacob's here.
This is the IRTA2. It essentially does what that little contraption that John told you guys how to build does. It is an RTA that you can use with any of the free RTA apps on your phone, but it has the capability to show you the left channel independently, the right channel independently, and you can also sum the left and the right channels with this. So if you're doing more advanced troubleshooting, you can look for things like all-pass filters, you can look for time delay, and you'll be able to see all that using the RTA. But the problem that we were running into with it is that if you guys look, it uses a 3.5 mil to 3.5 mil that comes with it, or that's just what you would use normally. So we had been using it with the old iPads, so that 3.5 mil would go straight from the IRTA2 into the iPad directly, and there's nothing in between. So it would work great.
Which you saw it. It does work great.
Yeah. So we got new iPads as a department, and these don't have a 3.5 millimeter jack on them anymore.
Kind of like my phone.
Yep.
Now the phone has a flat output. We just verified that.
The phone does have a flat output, but what we discovered is, before we were delving into all of this, we used a couple different types, or we tried to use a 3.5 mil to USB-C adapter. Now the problem that we ran into is that no matter which adapter that we used, whether it was a Samsung or I think I bought maybe 6 or 7 different types of adapters from different companies and tried to get them to work with the new iPads, and the DACs in these adapters all gave different results. For example, the Samsung one that I got with my Galaxy when it was brand new wouldn't even work with the iPad at all. It wouldn't pick up any sort of a signal coming from the RTA. The ones that I got from Amazon had a terrible frequency response, and they all had different frequency responses when I used them with the RTA. The one that seemed to work the best was the one made by Apple, but it had some sort of I think it was a low or a high pass filter on it, and the low frequencies were rolling off. So it still wasn't perfect, and I'm still working on trying to find a solution for that so we can use the new iPads with our trainings. A DAC, if you guys aren't familiar, is basically a digital to analog converter, and that's what you have in laptops for your HDMI outputs. That's what you have, some little chips in these dongles that allow it to work basically with your phones. But
which is amazing to me, the fact you can have a little computer chip inside that little $8 cable.
Yeah, but as I explained,
I'm not happy it's in there.
Yeah, well, each one is different, and I still haven't found one that gives us an acceptable frequency response working with the IRTA2.
Well, even with this, and we're going to show that to you right now. Go ahead and give me that plug. So I'm going to plug the little apparatus you just saw work so perfectly with this new iPad. And Jacob, I'm going to go ahead and play pink noise back on my phone. Go ahead and measure the...
I lost my cable. Oh, is this it?
Yep, that's it.
Cool.
So I'm going to plug this in. Same thing as we saw before.
And yeah, this is the same signal, guys. This is the same everything except with the adapter in between.
So you still see that little bit of noise.
Take the iPad a little bit towards you, John. Get it out. There you go. That'll work.
Oh, I can see it. There we go.
We got some glare, guys. Give us
all
just
right.
a sec.
So there's the iPad with that little bit of noise we talked about. Now let's go ahead and send the pink noise into that. Now that's sine wave. What do you see?
Yep, so this is that Apple adapter that I was telling you guys about, where it has a high pass filter on it. And it looks like all those low frequencies start to roll off pretty high up there, so we wouldn't want to use this for our purposes. We're trying to use the IRTA2 to show what the key lock is capable of at different trade shows. So what we would do is show the before and after of the key lock signal correction. Well, we can't do that if we don't have a flat signal coming through to the iPad, and it's being colored by the DAC. So where's that other adapter?
I was just going to say, I know we got another one around here.
It's red, so it should be easy to spot. Oh, it's plugged into your phone on the other side.
Oh yeah. So we'd actually need 3 of them to do it that way.
Yeah.
So we had to come up with a way to get, the signal is flat going into the iPad. It's just not passing through this cable. Actually, it's not going into it. It's coming up to this point. So the cool thing about the IRTA piece is it's got basically everything built in that we showed you with this. So this does that, but with 2 channels. You can actually put 2 sets of leads. So where these are monoed together, you can put 2 sets of leads, and you can do the same thing with this simple handmade apparatus, or you can buy it already pre-made with switches, so it makes it really kind of convenient. The other thing you can do with the 2-channel setup, this is something else that's really interesting in audio now. You would assume that automakers always wire their speakers correct polarity, wouldn't you?
Yeah.
Wouldn't that make sense?
I can think of one that I know for sure that doesn't.
So yes, what we're talking about is almost all the Chryslers with the 6x9s and the 3.5s in the dash. That upper left 3.5, the driver 3.5, is wired out of polarity. So you can do that with a polarity checker, which is another great test tool. We need to show that one of these days, and those are like 12 bucks on Amazon too. The tools are not all that expensive, but they're very important. Because if you've got a speaker that's out of polarity, you're never going to get staging and imaging right. It will not work. So with this, with being able to measure both sides at the same time, if I measure one side, I have a flat frequency response. Measure the other side, I have a flat response. I sum them together and the signal completely drops out. Guess what? It's out of polarity. Doesn't matter what it says in the manual, doesn't matter what it says on the website, whoever put it on there, it's out of polarity. In fact, the 2017 journey that I had that we first found that out on, I mean, I bet I went through that thing 6 or 7 times checking all the wiring, just could not figure it out, it just didn't sound right. Finally, Joe went home and grabbed his polarity checker, and sure enough, that left dash speaker was out of polarity. You could have told that by hooking the RTA, the dual channel RTA up to both dash speakers, you'd be able to tell which one or if either one of them were out of polarity. So what we're going to do now is we're going to talk about one other piece you may have to get. It's not overly cheap.
Before we move on, why don't we show them what the tone controls on the deck do to the RCA signal? Or
yeah, we might as well, or we can do it when we hook that up too.
Okay.
Let's go ahead and hook this up. This is kind of an interesting piece of equipment. This is called a Focusrite. It's made by a company called Scarlett. I don't know if you want to zoom in on that. Yeah, Focusrite makes it. Scarlett is the piece. Sorry about that. I got it backwards. So anyway, this is a mixer. You've heard of mixers. I mean, not like the kind you have in your kitchen counter when you're making no-bake cookies.
Like KitchenAid.
Yeah, exactly. But this is an audio mixer, and you've seen the big consoles and recording studios. This kind of does that, but in very simple form. This is a 2-channel. There's 2 versions of this. One of them is a single channel. There's another one that we have right here, which is a 2-channel. So it's got 2 inputs. So this way, I can actually measure 2 signals at one time. I can measure the left channel and the right channel. And what's really cool about doing that with a sine wave, if you have left channel and right channel and you go into a dual trace oscilloscope like we had on the laptop or we have in the ePook, you can see time alignment.
Yep.
Because if those waveforms are not, in alignment, you have some time shifts. So that's another great way to test for time delays with a sine wave and a dual trace oscilloscope. You can't do that with an RTA. You can do it by summing the signals together, but we don't want to go too deep that route because we don't want to confuse people a whole lot. But this piece, in fact, what I've got here is just a 1/4 inch to 3.5 adapter. There is also other adapters. This is an RCA to XLR.
Here, use this one.
No.
I'm messing with you. I handed him a pin.
So this is called an XLR connector, which it has a positive, negative, and a shield. So there's actually 3 wires, where most audio wires are just basically a shield and a center conductor. So there's 2 different versions. This has got an RCA to XLR. This is a 1/4 inch to 3.5. They do exactly the same thing. So what we're going to do is we're going to go ahead and take the Focusrite, and this will send signal to the iPad through the USB-C. So go ahead and plug that into the USB-C, Jacob. Now we don't need that line to mic adapter. So now what we're going to do is we're going to go back to my phone. We're going to play Pink Noise and remember what that signal looked like. We've got to plug the signal into here. I got to figure out where the output for the phone went.
Right here.
Aha! He's hiding it from me.
There's just so many cables on this table, guys.
Like I said, I knew we were going to have a lot going on. All right. So I'm going to plug this in.
Start moving stuff out of the way.
And I don't think we got this plugged in all the way because it didn't trigger. Come on. Switch.
Let's try.
There it goes. All right. So now if you notice, we have no signal. The Scarlett does have gain control. That's what I showed you before when I was adjusting the gain control.
This cable.
So we're going to go ahead and play the Pink Noise. Now look at that. that has got a good flat frequency response. And if I turn the gain control on the Scarlett piece, you can see it go up and down. I know I'm going to bring this over here so you can see it in the screen. So you see the flashing ring around the gain. Green is good. Solid green is better. Orange tells you you're getting close to clipping. Red is clipping. And you notice you can't see clipping on the RTA. But so you always want to make sure these stay in the green zone, so that you know you're not clipping the input to the Scarlett. So now, with this new iPad, even with those funky, D to A converters, you can still use an iPad. Same thing with a laptop if your laptop doesn't have a microphone input. In fact, I use the Scarlett for my laptop because a lot of laptops have that exact same problem. They have a filter on the microphone.
And John, how many laptops have you burned up by running speaker level directly into it?
0. Never burned up one. You're thinking of the one I burned up because I plugged the phone line.
Oh, that's right. Yeah.
It actually was a phone line. If you guys don't know, phone lines have 42 or 48 volts on the phone line. And it wasn't a network cable, but it had the same exact connection. It wasn't labeled. So I plugged a phone cable into my laptop thinking it was a network cable and let some magic smoke out of the network adapter in the laptop. So that was the end of that. And in fact, I actually, it doesn't bother me much. I still bought that same laptop back when the company sold it when we got new ones. But that's what happened. We got new iPads. So when we got the new iPads to stay up to date, we noticed that we had a real problem with this RTA. So we came up with, actually I got to give Kip credit because Kip was the one that suggested we use the Scarlett piece to try that. And it works great. So that it also works with the laptop because with the microphone input on a laptop, if it does have a 3.5, you can't do dual trace. It's only got one input. By using the 2-channel Scarlett piece, I now can run 2 channels into the laptop, and I can see left and right channels. I can see time alignment. I can see everything, basically. So the Scarlett piece, I think, Ernie, do you remember, is the single channel isn't about $100?
Probably so. They have a whole line of products, John.
Yeah, they got a bunch of stuff.
Yeah, those are professional audio. And the only difference between that and the little cable you have is that a professional DAC with your hand right there. That's the difference. It's a professional audio device.
And that's why it's a flat response. It's designed for music. It's designed for the recording industry. And this isn't the only one out there. When I was in Africa last month, they're actually Sharp distributed. They do Sharp microphones. Sharp has got a single and a dual channel, same thing, and a plug-in. They work exactly the same.
So these days, John, most
Hope you guys can hear Ernie.
most of these audio interfaces these days will plug directly to the iPad because the iPad is a USB-C. Most of those will work and most of them are flat.
So as you can see, we're just USB-C. And go ahead and unplug that from the tablet. You see it powered off. So this gets its power through the USB-C from the iPad. Or what we're going to do now is we're going to go ahead and hook it up to the computer. We got any good questions coming in, guys?
I've seen them highlighted. It looks like 12.
12 questions.
Yeah. Does a KISS load 4 regulate the speaker output, or if the head unit is clipping, is the signal to the amp going to be clipped? So, Anson, the KISS load 4 only shows a load to the radio. It does not do any sort of signal processing. It doesn't regulate anything. What comes in is what's going to come out, but its purpose is to keep the factory radio on and playing. So some factory radios require that it'll send out a little pulse or a sweep or something if, sorry, I was looking at the wrong camera. It'll send out a pulse or a sweep or something to see if there are speakers connected to the speaker outputs or if there's a short in that system. And that's what that KISS load does, is it tricks it into thinking that speakers are still hooked up, so you keep your audio output. What do we got next?
Oh, I'm looking for my leads. So we've got so many cables going. Should have another set of.
So if you use speaker outputs to feed a KISS load, to feed a CX series amp, how can I tell if my speaker output is sending a clipped signal to the amp? So in that case, you would want to use an oscilloscope and do like what we talked about. You would play like a sine wave within your band of intended frequency usage. So if you're doing a sub, do 50 hertz. If you're doing 4-range speakers, do 1,000 or whatever. If you know what frequency is the highest energy, then measure that frequency. But you just turn the volume up and watch for clipping on the oscilloscope, like what we talked about before.
You had them.
I had what?
My leads I've been looking for. Wasn't my fault. So I'm going to show you a couple other things real quick. I'm going to disconnect this.
We want to knock out these questions first?
Yeah, might as well.
Okay. What's next? How do you fix it so that your phone or nav audio doesn't go to the rear speakers? Running front stage with key lock into key 200.4. If the fix is 2 key locks, what does that setup and wiring look like? So it sounds to me like you're using, so you're only getting your front inputs into that key 200.4. And your key 200.4 is dividing that front input and sending it to the front speakers and to the rear speakers. So the solution is to use 2 key locks, and you would take a second key lock and use that on your rear left and right channels, run the processing, and then connect that to amp 2 on your key 200.4. And that should solve your problem. You should only have your phone or your nav audio coming from the front speakers at that point. Oh, and turn your fader switch on instead of off.
Correct.
How would you test and or set a factory system with an LC2i Pro for sub for clipping? So in this case, you're going to want to find the clipping point of the factory radio first and use that as your point to set the volume. And then what you're going to do is move your oscilloscope leads to what's coming out of the LC2i Pro, do all of your tuning and adjusting on the LC2i Pro, and watch for clipping on that oscilloscope. And that way you're measuring the end result of your audio signal, and you can see what changes you're making to it with the LC2i Pro.
Yep, you always start at the top of the chain. Start with the source unit, then go to the next processor, then if you have another one, and go down the chain till you eventually get to the amplifier, and you measure the clipping coming out on the amplifier. Now, a good thing you mentioned that, and it's great. As I mentioned, this little guy right here handles 55 watts of power. So if you're trying to measure the clipping on a 1,000-watt amplifier, what do you think's going to happen to this? It's probably going to go up in smoke. That's why that lead that I showed you right here with the oscilloscope that's got the ×10 switch is really, really handy because it gives you ×10. What's really cool about the YPOC is not only does it have a ×10 switch there, in the setup, in the software, there's a ×1, ×10, and ×100. So that's how you can step that voltage down so you can see it. So that little guy for 150 bucks is really pretty darn cool. Wow, we're already 8:30. I knew we were not going to get through everything tonight.
Yep.
It's too much to cover.
One other thing, if you're trying to use an RTA like that with something that can't accept a higher level voltage signal like the YPOC, then that's where that IRTA2 comes in handy, because that can accept up to a 40-volt input signal.
Which is 400 watts.
Yep.
So these little guys are very handy. These are piercing test leads. So what will happen is you've got this little channel that you see. You pull these 2 little tabs down and it pulls back the sleeve. Slide your wire through here, let go, and then you screw the end in, which basically, and I don't think you're going to be able to see this, there's a little needle inside here. Yeah, you can kind of see that needle. That pierces the wire and that sleeve holds it in place. Then you can take your test leads, and these literally plug in. So you don't have to hold it. These will keep themselves. If you're trying to probe a wire that's completely sealed, like in a boat or a factory OEM connector, and you can't get to any bare wires, and trying to pierce the lead with this is a pain in the butt, or I should say a pain in the finger, because you always stab your finger and end up bleeding. This is a great way to do it, especially if you're doing left and right channels, looking for all pass filters, or you're looking for polarity. It's really hard to hold 4 test leads on 2 different sides of the vehicle.
Yep.
So these are really handy.
Just make sure you don't pinch a fiber wire, or you won't know what you did wrong.
Or an airbag.
Yeah.
Yeah, do not probe airbag wires. So you need a little bit of brains and common sense. If it's a bright yellow wire, that's probably an airbag. Don't probe those. So these are not overly cheap. They are $40 a pair on average, but they're very, very handy. In fact, I got 2 sets of them. I'm going to go ahead and use the other set right now for the next thing we're going to do. So I'm going to plug these right into the speaker outputs of the amplifier. And then I'm going to go back. Getting all confused. We're doing too darn many things here. So I'm going to go to my head unit here. And I'm going to go take this out of. That's the other thing I like about the True RTA program, is it does both oscilloscope and RTA. So now I'm going to set this to RTA. I want to use the output of the radio coming into the amplifier. We're going to play pink noise this time. And I said go. All right, so somewhere. I say a lot of wires to trace down. That is wire right there. I didn't have it plugged into. So this is the output. We're probing the speaker outputs of the amplifier. Remember, this has got a capability of more power. So I'm not going to use this at full volume. I'm more looking for frequency response, not clipping. So from whatever speaker output to line level to the input, I don't need to use that line to mic adapter because the Scarlett piece does that for me. Let's go back and play the pink noise. I know I'm going to get it to work here in a second.
We'll do a question.
There we go.
Yeah, let's go ahead and do a question, I guess.
Go ahead, Jacob.
Does anybody know if a key 200 amp does what a key lock or even an epicenter would do? So all of these products do a little bit different things. The epicenter will restore and add audio signal to your bass output. The key lock tries to make your audio signal, it takes a full range audio signal, not just bass, not just treble, full range audio signal, and it will make whatever corrections it needs to make to get a flat frequency response, which is great for those of us that use DSPs. It also removes all pass filters. It gives you a blank slate to start tuning that car. The Key 200.4 is a little bit different. It uses a microphone and listens to all of the speakers in the car, listens to the speaker locations, and it adds time delay. It adds our optimized EQ curve to that audio system, or what the engineer that designed it thought sounded good. So it is adding processing to this system to try and create a good one-seat tune or a good soundstage in your car, whereas the key lock is removing all of these things from the system so you can add your own tune, and the epicenter is purely for subwoofer applications and
simulates lower bass.
Simulates lower bass. Yeah, exactly.
So cool. All right. So if you can see the laptop, which you can even see it in this big wide shot, that is coming out of the flash drive. That is pink noise coming out of the flash drive. And if you notice, it's not perfectly flat because that radio may not be perfectly flat. And as we change the tone on the radio.
What are we adjusting here, John? Bass, treble?
I don't know yet.
Okay.
So we're just going to go to the preset EQs. So I just switched it to rock. Notice what it did to the EQ.
Looks like we got a little bit of a bump at 6K, at 3K, so it's giving it a little bit more sizzle on the top end.
There's pops, whatever that means.
Pops.
There's easy listening. Get out of the view of the screen there. Jazz. So you see, every one of these has a different EQ curve.
What's the scaling like there, John?
On the left?
On your RTA.
So between these numbers on the left, that's 6 dB. That's 4 times the power or 4 times less power. So that tells you what difference you have. So as we change the different sources, so natural is no EQ, and in fact, users where you can pre-program the bass and treble. But we're going to leave this on natural since that's the flattest response. And we're just looking at that RTA. It is a fairly flat output. That's more than acceptable. That's running from the pink noise on the flash drive. If we remember, we measured the pink noise coming out of the phone with the actually it was the USB-C jack. That was a pretty flat response, wasn't it?
Yeah, it was very flat.
So we always suggest you use Bluetooth to set your frequency response, right, Jacob?
No.
Why not? Why do we not recommend Bluetooth? It's compressed. It does a couple other things. I'm going to switch this radio over to Bluetooth audio. I'm going to go ahead and turn the volume all the way up on my phone. I'm going to play Pink Noise from my phone. Look at that.
Oh, man.
That is the Bluetooth frequency response.
It looks like, well, everywhere from 2K up, you've got, what is that, 612?
Well, Jacob, let's actually look at it. We click on this. We're at
26
dB output at 20 hertz to
minus 11, so 15 dB difference.
15 dB decrease in bass response. That is huge. So if you guys wonder why you don't have very good bass when you're playing your music through your Bluetooth, that's why we always recommend play your music through a flash drive, especially your setup tunes. Play it through a flash drive so you know you're getting the best signal possible.
Now, I know that there is a difference between different types of like Bluetooth codecs that you can use, and I don't fully understand it, but there are some codecs that allow you to have pretty high quality audio. Just most of your radios and most of the things that you would play music through don't use the codecs that allow for higher quality.
Yeah, that's the software that decodes or encodes the music.
Yep.
And you got to have good codecs on both ends. If you got a good encoder, but it doesn't decode it, you're not going to get the signal. And if you don't have a good signal, doesn't matter what you decode, it's still not going to make it any better.
Yep.
So that's what the codecs are. They actually code and encode the digital to analog. But that's the Bluetooth frequency response coming out of the phone, which is the same piece we measured. Well, actually, we can do that. And here again, with everything going on in the room, let's just go ahead and do that comparison once again. There's Bluetooth. And then I'm going to switch back here to the USB. You'll see it switch. There's your USB frequency response. And if you notice, the bass takes a little longer to rise. That's because on the right side over here, you see this 10 down here. That's its averaging. I mean, this is a really cool program. So I can set it to 2, which means it's going to average things together much quicker. And all this darn static, because there's something else I want to show you guys besides that. So it's going to average a lot quicker. But what is also important is you can set the high and low dB levels on the scale with this, where we can't do that with the iPads. There are programs that will allow you to do that. But more importantly, this is a third octave, so about 31 bands. If we go to a single octave response, that means every time you go to the next bar, I'm sorry you can't see me pointing, but you start from the left, you go to each column, it doubles in frequency. That's 1 octave, because you double frequency is an octave, or you half frequency, it's an octave. So an octave is not really the best RTA. And you get the free version of True RTA, you get the single octave RTA, and you don't get the oscilloscope. If I go to the most popular that we use, that's a third octave. You see it divide that into more parts. So now rather every octave, I've got 3 steps in between each octave. So that's a third octave. What's really cool about this program, not trying to sell the program, it does a 6th octave. Ernie, if you can go back to the laptop, you see a bunch more columns, a lot more sophisticated response. Is that the end there, Jacob?
I don't think so.
It has a 12th octave. If you really need to know what frequency that is, and obviously we're going to go one step farther, there's 24 divisions per octave. There's only 7 notes in each octave.
Yeah, for most of your, our applications as far as tuning vehicles, we generally just use a third octave RTA. But if you guys really want to get crazy, like John said, 1/24 is available to you. But this is where, if you guys are familiar with what time delay looks like on an RTA, this is where you would really start to see your notch filtering with the 1/24 octave RTA.
So I'm going to have some more fun here. I'm going to go back to, let's go back to 6th octave, just for fun. So in the software, we're using an IQ amplifier, which is all DSP based. So this is with the EQ set flat on that channel. I can show you what happens if you put a crazy EQ curve on it. So if you notice, you're going to see the big peaks at around 500 hertz, then it drops at 1K, then you get another peak at 2K.
Looks like the Grand Canyon.
Yep, so that's what you can see. In fact, you can adjust this. So what I'd want to do, if I was tuning a system and that was a microphone response, is I would want to start tuning everything down to get rid of those peaks and valleys. So you see how it gradually changed. Or I can just hit defeat EQ. So that's some of the DSP software that's built into the IQ amplifiers. Sorry there, Stephen. Speak up, you can talk. Ernie talks. All right, so go back to the laptop there, Ernie. So now that we see what a flat response is, let's go to the software setup. Let's turn on a crossover and see if you guys can tell me what crossover I just turned on that amplifier. And something else happened we're going to talk about. That is a 500 hertz crossover.
24 dB per octave?
24 dB per octave. So what's this big lump down below where it rolls off?
Power supply.
Exactly. If you notice, that's centered at 60 hertz. What frequency is AC current out of the wall?
60 hertz.
60 hertz. Yeah. So that is power supply noise. I'm going to unplug the charger for the laptop, and it should diminish. Apparently it's not, and it did.
Oh, it could be it's sitting on top of it.
So yeah, remember you've got those weird noises, but let's see what a 12 dB per octave would look like.
See, we have, see how that slope isn't quite as sharp now, but sometimes, when we're even at trade shows when we're trying to show the RTA with what the key lock does, you can see that power supply hum, and sometimes it's there, sometimes it's not. So we can also sometimes get interference from other stuff in the room that's not even directly connected to the RTA. So
experiment a little bit. I mean, if you turn the volume all the way down and it doesn't move, that's a pretty good indication that's noise.
Yeah.
And you see all the other garbage down here, that's harmonics of that. So if you turn the volume up so it's beyond that, you've got a good response that you can read. So that is a high pass signal. Well, here's a low pass at 5K.
Yeah.
So this would be great for mid-range. See what the 12 dB per octave version looks like?
A little bit less steep.
Shut it off, turn it back on. Now let's turn on both at the same time. And that is what we call a bandpass crossover. That would be the signal you would send to a mid-range. Actually, probably in a three-way home speaker, this would probably be about where to be, because you've got from 20 up to 500 hertz to be where the woofer would play, and it's technically not called a subwoofer at that point. They just call it a woofer, because the difference between a subwoofer and a woofer is the frequency they play, not the speaker itself. So that would be the signal you would send to a mid-range in a passive crossed over home system, because to have a crossover at 100 hertz would be a really big, heavy coil and would really rob a lot of power. So it's pretty cool what you can see with the RTA. So you can see exactly what signals go into the speakers. You can see where clipping is. Now, as I mentioned before, the ye old voltmeter here, this guy is important for setting gains as well. So if I were to, I think I can go to the output of the amplifier, unplug the RTA and plug this into the amplifier. Down here.
Oh, okay. Yeah.
So now we're going to take the little digital multimeter. I wish there was a way to make this thing stand up, but it doesn't have a stand.
I think that's, one of your leads is bent here.
It should still plug in. All right. I have no idea what this radio decided to start doing. It decided to start scrolling. That's what it decided to do. We don't want pink noise. All right, let's go back to a sine wave. Come on.
Let's get another question up here for me.
Hey, go right ahead. I figure out why this radio is not showing me the tracks anymore.
Will a KISS lock dynamically watch the signal coming out of a Starlink module in a Subaru to constantly flatten out the radio signal and time alignment as you go up and down the volume?
Nope.
No, it won't. Thomas, a KISS lock is purely a passive device. It doesn't have any sort of signal processor on board. All it does is knock that voltage signal from up to 10 volts down to 5 volts or less. Let's go to the next one. Two-part question. Do you see any benefit to running a key lock in front of a key amplifier? Yeah, I do.
Absolutely.
There's several benefits to doing that. So a lot of modern vehicles have all-pass filters present, which kind of give that vehicle a two-seat tune. It makes it sound good for the passenger and for the driver. If you're trying to install a key 200.4 and add time delay to the system, that could cause all sorts of problems with how the system is going to sound. It could cause problems with the time delay. It could cause all sorts of things. And if you have some sort of wacky, crazy EQ curve in that car from the factory, maybe the key lock, or excuse me, the key 200.4 wouldn't have enough processing power to try to reach the level of whatever frequency it's trying to adjust. And so, you know, with the key lock, it has up to, I think, 24 dB adjustment on any band. So
18.
18, excuse me. Yeah, 18
You're close.
dB of adjustment. And then you can throw the key 200.4 after the fact and add our optimized EQ curve to that audio system. So you can get it flat and then get it to sound good in that order.
Yay.
Also, will Kicker release a bigger key amplifier? Stay tuned. That's all I'm going to say on that. If you've already got the Key 200, but a factory Toyota radio, do I get just a key lock or an LOC plus an epicenter? So that depends on your application, but if we're talking purely the Key 200, then I would just say get the key lock because it is an LOC as well as a signal processor that's going to bring it completely flat before that Key 200 has to make any sort of adjustment. So that'd be my suggestion. If you have a subwoofer in your vehicle and your car has bass roll-off, that might be where you would use an epicenter or something like a Key 500.1 amplifier to compensate for that bass roll-off.
Cool. All right. Now we're going to go back. I'm going to go ahead and have you unplug that. I'm going to have you hold those on these leads right here.
Okay. Let's do one more while we're getting set up for this. I saw you guys threw one up there for a second and then pulled it off. Are the Kicker CX amps, specifically the 1201 and 360, start-stop compatible? Ramon, yes, they are. They function down to 8.5 volts. So when that car restarts, when you push on the gas pedal, that voltage is going to drop, but 8.5 is low enough that it's not going to go into protection mode when that happens.
These guys are being smartasses.
Yeah,
back
I know
here.
they are. He drew a whole freaking...
And he's talking about all the sharps and flats, that there are more notes in an octave than
Yeah, yeah. So technically there are 12 notes in an octave when you count sharps and flats, and he wrote A sharp, B, C, C sharp, D, D sharp, blah, 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 blah.
Yeah.
So yes, you are correct.
Smartass.
And everyone's numbered.
Yeah, exactly.
Yeah.
All right. So we know with this radio, when playing on the flash drive, I can run to 34 before it clips on the output. Let's see how much power that really is. Let's see what the voltage really is. So I'm going to go ahead. He's holding the leads on the meter to the speaker outputs on the radio. Let's turn it up to 34. You see the voltage continues to climb. So we got 14.5 volts at 34. And if we go down to 28 where we were before, we're down to 5.9. So if you notice, every click on the radio is a substantial increase in output. So if we do the math, we could actually multiply 14.3 times 14.3 and divide it by 4 ohms. That'll tell you how many watts this is putting out. But more importantly, it's putting out 14 volts of clean power. So once again, if I have an amplifier that only has a 10 volt input, I don't want to run the radio up to 14 volts because you're clipping the input, you're never going to get a clean output. So I'd want to turn the radio down till I was under 10 volts. So we're at 9.5 and that's volume 30. So now I know I've got 9.5, roughly 10 volts is 25 watts. So I've got 25 watts coming out of the head unit or approximately 10 volts. So perfect. So for this IQ amplifier, it has a maximum of 10 volts in the input. So we're perfect. We want to set the gain with the radio at, I think it was 30 here before I get too much voltage to the input of the amplifier. So what do you think, Jacob? Do we have any fun?
Yeah, I think so.
So obviously the contest ended a while ago, registering for it.
Yeah, so let's, we need to get those guys their prizes.
Yeah, well, we still got some other things to do.
Oh, that's right. We
Still got a few more minutes, guys.
Housekeeping. Hey, one more thing. So when we were looking at the voltage output level of that radio, and John said that 30 would be a good point to set the gain on the amplifier. If you guys remember, back to the beginning of the show, we found that that radio actually clipped at 28 on the volume, despite the correct voltage level being 10 volts at 30 on the radio. If you're just aiming for that maximum input voltage level on the amplifier, you may have already been clipping the audio signal from the radio. So that's why it's important to have all of these tools in your arsenal so you can see when you're clipping instead of purely looking at the voltage numbers.
And you got a good point, because we did just measure the speaker output, which we said it clipped at 28. Well, that showed at 28 we were at 10 volts, and I forgot that, yeah, we were measuring the speaker output, not the RCA output. All right, I think we've got a few more fun things to do here. I need to go to a file, and then we'll see what other kinds of cool questions we have. Go to today's file. What do you think? Should we start with fails or installs?
Fails.
Fails. Fails it is.
It's my favorite part.
All right, Ernie, let's start with some fails. And I say Ernie because Ernie was kind enough to send these to me before the show.
God.
Holy cow, I haven't even looked at them yet. So
What is going on? Velcro holding the radio in.
I'd say that's a fail, wouldn't you?
Yeah, I mean, if it works. You know, this is never something we'd want to send out the doors of a shop, but, you know, for those vehicles that you paid, you know, a dusty nickel for, and you just want some music in there, that's, I mean, to give the guy, you know, some benefit of the doubt, maybe the bracketry that holds the radio in had been removed for whatever reason or damaged, so he had to use Velcro to get it to
actually,
stay put.
as you're looking here, there's the knobs for the factory radio. That's where they would go through the display, and it's been hacked off. So,
Oh, man.
yeah, and I can tell by the controls it's a Ford, but yeah, they hacked the crap out of that one. So that's a fail. Once again, no offense to you guys if these are your installs. Just hopefully you keep watching the show and learn by them. Man, I really hate this.
I'm going to
mouse.
confess one of my own early audio fails.
And we've all had them.
My first ever car was a Pontiac Firebird I bought for $500, and I remember the rear speakers in that car wouldn't work in the sail panel. So I took the sail panels off and decided to try and see what I needed to do to replace the speakers, and I bought 6x9s because that's what online said they were. And I tried to put them in and they wouldn't fit. Well, somebody had cut out the sheet metal with shears in the back of that car so that the speakers, whatever speakers were in there, got stolen, and they cut the metal to get them out, and new speakers wouldn't go back in. So I hung those speakers back there. I drilled some holes and used zip ties to suspend those speakers in the back of the car.
And we've seen those pictures, so not of your car, but so here's an example of someone spending way more money on the product than they do the install.
Oh, God.
Yeah, and your cardboard is not a good baffle. I'm really not sure if that's another wire there. If that, anyway, it doesn't matter. So that's a fail. This is. Oh, the next picture. Okay, so Ernie's giving me directions on these pictures. Okay. There you go. So there's the amplifier, and that's a. What is that? A Bic pen? It is.
No way.
It's got a round point, so yeah, that's a nice little standoff, you know, and I like the fact that, you know, you can tell that that's a drywall screw.
That's a drywall screw.
Screwed through metal, and yeah, it's not even tight. Look how loose it is. That amp's going to rattle. It's going to be annoying. Here's another great one. How about duct tape to hold your power wires on your battery?
I like that the battery's sideways sitting on top of the valve cover.
Yeah, there's that too. And
See, the original battery's
still there.
Still in there.
I gotta zoom in on this one.
So the original battery is still there, and they duct taped some of the insulation from the inside of the hood to the top of the battery.
But what's this?
What is that?
That looks like it's another bare connection. I mean, that looks like, that's a ring terminal that's crimped, and who knows where that wire goes.
Yeah, so when we say that you need to add an extra battery to your system, this is not what we mean.
Yeah, well, we do mean add an extra battery, but do it right. Oh, and where's that fuse?
There's not a fuse.
Yeah. And wait till that battery, rubs through the case of the battery on the valve cover.
Yeah, jeez, man.
Fire extinguisher mounted in there too.
Yeah.
And here's the other thing. I mean, I'm really thinking that's another Ford. And not that I'm against Fords, because I own one, but this really is reminiscent of a Ford cowl. So I don't know if it is or not, and someone can probably correct me if I'm wrong, but
It looks like a Ford alternator on there too, I think.
and there is one thing we can say for sure about this: it's a fail.
Yeah, definitely don't do this.
It's
Please.
a hazard, and I have no words. Installed my stereo and light bar last week, having trouble shutting my door. How did you all run wires?
He's got hose clamps in there.
I don't think they're all. I don't even know what he's got in there. Let's take a closer look. What in the world? I mean, is this mess and these nice little cable clamps? But look at where it's pinched.
Yeah, exactly. I mean,
Right here. Do you think that's shorting out at all?
You almost gotta wonder if it took more effort to do that than it would have taken to just run them the right way through. Because look, it looks like he tried to seal off where the wires go into the side of the dash there, or maybe that's just gunk from the, I don't even know, man.
And I hope that's plastic, because if that's metal, there's no grommets, that's going to short out.
Yeah.
It's ugly however you shape it. All right, so that's enough of the fails. Let's go to some installs here. Couple cool installs I found on the internet. That just, once again, nice clean install.
I love the Honda logo.
Yeah.
Involving that in the build. That looks great.
And it just, L3s.
We don't have a picture of that when it's dark, do we? I bet that looks awesome.
I bet it does with the lights, but I like the trim ring around the woofers, nicely done. But L3s, we haven't had those for quite a while. So, old school gear, but that was a nice looking woofer. It still is, as a matter of fact.
Kind of fits in with current lineup.
All right. I liked this one, being kind of a motorhead.
Oh, that's cool. It's like a 6-cylinder engine with
Yeah.
speakers.
And I don't know if these are ports for the speakers. I think they're round. I think they're 6.5s with a 10-inch woofer. So pretty cool. But look at the radio. Looks like it's the carburetor.
It looks like an air filter. That's awesome.
Give it like A+ for creativity. So
That'd be an awesome shop radio.
yeah, I'd be curious what it sounds like. And as soon as Steven gets out of the way, what he's writing over here, we'll know what he's saying. SEMA break. Just to let you guys know, the next show will be November 7th, because we will be in Las Vegas. And no, don't get all excited for us. You might. I mean, I like the SEMA show. It's one of my favorite shows, but I hate Vegas.
You should try following this guy around at SEMA. He's like a shaved squirrel, just trying to. I don't know. He said
Now
shaved
I'm
squirrel
curious.
earlier, so I'm throwing that in. But he walks around so fast everywhere, like.
We're gonna put a GoPro on his collar for seeing.
It'd be like those cat videos where they're like walking through the
Collar,
alley.
belt buckle, whatever. Anyway, I love this install. Go ahead and go back to the picture, Ernie. This is really cool. This guy's audio is shot. Ernie, there you go. How about that for cool? Actually recessed a little lever action rifle in the back of the seat.
That's neat.
And yes, it's not our gear, but it's still absolutely gorgeous installed. And that looks like it might actually be real chrome around everything. So nice kick panels. I mean, nicely done. So nice door panel. So beautiful install. And then we're going to show you a little preview, guys, of what you will not see if you, in fact, unless you're here or going to SEMA show. This is our own Chevy Sierra that's sitting in back right now that our masters, Tim Smith, Josh Fletcher, and Chase Alexander are putting together for the SEMA show. What are those, Jacob? What do those look like? Are those Solo X's?
Yeah, those are the L7X's.
But what are they?
What do you mean, what are they?
Badine.
It's 4 Badines.
Oh. Oh, yeah. Okay.
Those are the 15s. So for those of you that are questioning if we're ever going to come out with them, we're showing them at SEMA. So there are 4 15s, and this install is going to be really cool when it's done. And obviously, we're not to SEMA yet. Nice little placement, a little kicker badge, offset of the Power Sport speakers, just to dress up that door grill a little bit. And if you guys don't recognize the elbow hair, that is our one and only Bill Frog's elbow hair. Nice picture, Bill.
How would anyone recognize his arm hair?
Yeah, you give me crap because I knew he took the picture and he's wearing that shirt. So that's the only way I know. Put 2 and 2 together. So you guys give me crap about license plate frames and not. Anyway, here's the inside the back door of that vehicle. And what's on the wall there, Jacob?
CX Warhorse. I see a Warhorse in there.
You betcha. There is a Warhorse per pair of Solo X15s.
And you know, I actually haven't been back there to see this vehicle yet.
But we just took these pictures, what, 4 o'clock today, Bill? Something like that? Right after our meeting.
Nice excess power battery there. The wire's clean. It looks really good.
Absolutely. Here's the console. You notice you've got a display for each of the Warhorse amplifiers. So those read out current voltage, high voltage, and low voltage in the power cycle. That means from the time the amplifier's been turned on, it'll tell you the highest and the lowest the voltage was. It'll also tell you the temperature of the amplifier. It's got 3 color indicator LEDs. Green, obviously, it's running great. Orange, it's getting warm. Red, it's shut down from thermal, which will probably never happen. I was talking with the engineers, and they said, we've tried. We can't get the things to thermal. There's so much heat sink. And then they also have a protection indicator that tells you, is it a wiring problem, a voltage problem, or did you damage the amplifier? So a great little diagnostic panel, and those are machined aluminum. They're not plastic. And then this is the base control that also comes with the Warhorse amplifiers, which is also all machined aluminum. And they've got little magnetic brackets that you screw the bracket to the dash and they just snap in place. So nice, clean install. This thing's going to be amazing. Hopefully you guys out there will get to hear it when it comes to a show near you. And in the front doors, they've got the KS components, the 6x9s are in the doors with tons of hush mat in that vehicle. Not literally tons, but many pounds to make sure it's dampened and sounds good. And I like the way they sunk the tweeter into the factory grill. So just keep everything more as a point source. So great pictures. Hope you guys, when we get that whole thing done, the outside of it's going to get wrapped. It's going to be a great looking vehicle, and it's going to be loud.
Yeah. Oh, yeah.
It's going to be
loud.
stupid loud, so I can't wait to hear that thing. I know I'm going to get in trouble.
Yeah.
I know when we went to the Sand Sport show, we had one of our other demo vehicles that had the 615 L7s in it. And I don't think the people around us like me very well. I was having way too much fun with that thing. I'm really surprised we didn't break the windshield on that vehicle.
Really?
I mean, it was moving that far. Well, we ripped the console out of the headliner and broke it. I mean, it's completely unrepairable.
That is crazy.
But yeah, that thing's a beast too. So it's actually in the California market right now. But that is one of our Dodge vehicles, and it's got a killer system. And that thing played at the Sand Sport show for 3 days with me, just like wicking it wide open.
Oh, well, that was the problem.
Yeah, playing
you were the one
some,
running the
some
demo.
crazy, just bass me. Anyway, it was fun. A lot of people just were just in awe of that thing. So this 415s is going to be great too.
Yep.
So SEMA show. We'll be at the SEMA show. I don't know if we'll see any guys there. It's a industry only type show, but the last day I think they are selling tickets to like SEMA Ignited and some of that. I think they're $160 to go see a bunch of bands play and all the neat cars. So if you guys can get to Vegas.
Oh, they're having bands play?
Oh yeah, there's a bunch of bands playing.
See, I knew they were doing like the Consumer Day or whatever it is.
Yeah, but there's quite a few good bands that are playing, so it's actually not a bad deal. And the SEMA show starts on Halloween. So yes, we're going to be spending Halloween downtown Las Vegas. We got to be careful. If you've ever been downtown in Las Vegas on Halloween, they're not always costumes.
No,
that may be just their lifestyle. I remember seeing a guy, and I walked up to him and said, "Hey man, where did you get all that fake blood?" He said, "What fake blood?" Like, oh. That's real. No, anyway, never mind. Time to give some stuff away.
Yeah, let's do
Wait,
it.
questions. You got questions.
Do I have? Oh, yes.
Yeah, don't forget the questions. We almost forgot the questions.
Well, we almost did. We answered quite a few earlier. So this guy says, at high volume, my tweeters turn off in my KSE 6904s. That's a really common problem that we have. This last
Well,
time,
if it's a problem.
Well, it's not a problem. Well, it is, but not for
Not for the reason you're thinking.
This last time they turned off, they didn't turn back on.
That's the problem.
Is there something I need to reset or a fuse to replace? No, so you were experiencing our poly switch protection, and there's a thermistor in there that basically turns the tweeters off whenever you send a very distorted signal to it. It's keeping those speakers from burning up or the tweeters from getting toasted. Now, sometimes it doesn't fully prevent the tweeters from getting blown, and it sounds like that's what happened the last time when they didn't turn back on. So it sounds like we need to get our speakers replaced under warranty.
Hopefully they're under warranty.
Yeah, hopefully they're under warranty. If not,
Got a 2-year warranty on them if they're the KS. So.
Yep. Next one says, I bought a used SX amplifier on Facebook Marketplace.
Cool. I like those.
Yeah. I'm locked out of it and can't adjust the settings. What can I do?
Buy a new one.
Do I need to send it in to have it fixed? Actually, so this is kind of a cool little kicker history thing, but
Well, we can blame Kip on this one.
yeah, but on those SX amplifiers, if you got locked out, there are a couple different passwords that you can enter if you forgot your password, and one of them is Bonehead, and the other one is Doe, like what Homer Simpson says, D-O-H. So if you enter those passwords in, it'll actually unlock that amplifier and give you access back to your settings.
And there's 4 more, and I can't remember them. I know the guys in warranty back there, one of them's got them actually like burned into the edge of his workbench, I think.
That's cool.
I forgot to go back and look at them before the show.
So my KMC 10 radio is making a loud screeching noise when I turn it on, no matter the source. Do you have any ideas on how to fix it? Yeah, so I had this call once or twice when I was in tech support, and the way to fix it is to perform a factory reset on the radio. All you have to do is press and hold the play pause button, and that radio will basically cycle back to the factory state of the software, and it's fixed that screeching sound in the past. I don't know what causes it. It's not a very common issue, but when it happens, a factory reset is the way to fix it.
You know, it sounds like possibly since it's in a boat, the battery may have gotten low, and we know computers, they don't like low voltage, and so that's why resetting the computer probably helped it. It could have been something with the software just got locked up somehow because of low voltage. It had a electrical hernia, basically, which is possible. All right, now should we give away stuff?
Yeah, let's do it.
At least we're only at 9:10. We could be a lot later. All right, Bill Rollum, who is the 3rd place winner in tonight's drawing?
Curtis T. from New York.
Curtis T. from New York. Congratulations, Curtis. Watch for an email from Bill Frog. He's going to ask for your name, your address, your T-shirt size, and your phone number. So congratulations on that. 2nd prize winner is going to be, drum roll please, bring it on, Mr. Bill, Cameron W. from Utah. Same thing, Cameron. Make sure you watch for Bill's email. Name, address, phone number, and shirt size. He will send one out to you, and you people don't try sending emails into us saying, hey, that was me, because Bill has the emails. He knows who won. So you've tried. It doesn't work. Bill's pretty sharp back there. He does a good job. So the grand prize winner is Jacob. No, you're not the grand prize winner, but
No, I wish.
who is?
Fabio R. from Florida. Congrats. That's awesome. You get the bullfrog. Woo.
T-shirt and the koozie. All right. Well, if you guys had a good time, let us know. If there's stuff we didn't cover you want to know, please let us know in the comments. Support@kicker.com. We keep telling you that. If you got suggestions for the show, or if you got Bill's email, you can send questions, you can send suggestions to support@kicker.com. But we love your input. We love your support. Thank you guys for all your support. Thank you guys for tuning in. You guys have been great. You stick with us, show after show, and we really enjoy doing this. So help us with content, what you guys want to see. Thanks for your support. And I think we've given Ernie enough warning that he might be able to close us down.
So Andy's gonna tune in.
Andy's tuning in.
Show next week. And then we're gonna take that week off. And Andy's gonna take care of that too. So 2 weeks in a row, Andy.
All right. I don't know if you guys heard Ernie or not. Can't tell what you guys are hearing, but Andy will be on for the next 2 weeks. So thank you, Andy, for picking that up, and thank you for everything you do for us, Andy. Thank you to all the guys out there, Baba, Larry, all you guys. It's a pleasure doing this for you, and look forward to seeing you guys out in the real world at some of these audio competitions soon. So, guys, have a great rest of your week. And it got cold here in Stillwater last night, got to 34. So it's going to be chilly when we go out tonight. So, guys, have a great week. Tune in November 7th, because we'll be at SEMA the next time. So, thanks, guys. Have a good night. Take care. Bye.